posted it, you said part 1 and part 2, but when we're doing it on Test Wizard, is it only like one section?
No, it's 2 different parts.
Okay.
Yes.
So
Thank
wait,
you.
the 2 different parts are both on Test Wizard?
Uh-huh.
Oh, okay. Thank you.
They'll both say Thanksgiving part 1, Thanksgiving part 2.
Oh, okay.
Yeah. All right, ladies and gentlemen. So you guys can see my screen, yes?
Yeah.
Yes.
Okay, so we're going to do now Earth in the universe, whereas we've been doing Earth and the Moon and the Sun in conjunction with one another. Now we're going to see where our place in the universe, and specifically we're going to start off with the solar system is. If you're following along in your review book, it's pages 38 to 58. All right, so just a quick little review, celestial objects in our universe, right? So celestial objects are objects that will appear at all times, but we just will only see them at the nighttime. So if you pull out your phones, right, and go, or on your iPads and go on your night sky app, you will notice that even though you are outside during the day, there are objects in the sky that are still there. You just can't see them with your naked eye. So, for example, if I'm looking at it, right? Let's see if you guys can see that. Right, so the sun for me is directly in front and Mercury is slightly to the right, right? Look at that, all of these different places. Oh, look at that. It's kind of cool. Look, we got Jupiter over there, right? Just looking around by moving my phone. All right, we got Mercury and Libra's right next to it, and then Venus is right next to that. There's Virgo, right? So these are all celestial objects that if you go outside right now, the sun's light is blocking it, so you can't necessarily see it. Plus, you may not see it all the time, right? All right, so what are celestial objects, right? They include the sun, right? We know that's out all the time. We just don't necessarily see it. The moon, right? Driving home yesterday from picking up my kids from school and their daycare, they kept pointing out that you can see the moon outside. And what time did we get out? We got out at like 3 o'clock yesterday is when I picked them up. So if you guys want, go outside today after last period, and I guarantee you should be able to see the moon. It's about it's a half or it's a quarter or a gibbous. I can't remember which one it is. Right? So planets and stars, like I said, on the app that we were just looking at, right? You could see planets, you can see stars, but if you walk outside right now, you're not going to see them. Right? Comets and asteroids. Right? We'll get into more details about all these different parts. Right? And finally, meteorites and black holes. We're not going to be going into too much detail about black holes for 2 reasons. Number one, because the New York State Regents curriculum does not cover them very much because there's so much unknown right now about it. So we don't really have a lot to talk about when it comes to black holes because there's so much of it that's undiscovered. Say hi to Mr. G. All right, so, right, now since we're talking about the celestial objects, we also have to talk about how do astronomers basically measure the distance between 2 objects. Well, first of all, you're not going to use the typical miles or kilometers that we use on Earth because the distances are extremely large. So there are 2 ways that you are going to be responsible for knowing how they measure the distance. The first one is known as a light year. Okay? Told you. Okay. A light year is going to be a standard unit of distance when we're talking about celestial objects. So the distance between 2 planets, the distance between a star and a planet, a comet, an asteroid, whatever it is, we can refer to it in light years. Okay, so what is a light year? A light year is how fast a light will travel, or how much distance, I should say, light will travel in 1 year. It makes sense. Okay, and in order to do that, you need to know how fast light will travel in general. Light's going to travel 186,000 miles per second, or 300,000 kilometers per second. Make sure you understand this. This isn't per hour. This is per second. Okay? So that means, if you, to put that into perspective, right, 1 light year is about 6 trillion miles, right? You're going to want to highlight the definition of a light year, and also the fact that 1 light year is about 6 trillion miles. Those are important numbers that you should know. Okay. The nearest star to us is Proxima Centauri. It is about 4.2 light years away. So basically, if you take 6 trillion and multiply it by 4.2, that's how many miles away it is. Okay, so it's about 24.8 trillion miles. That's a lot. It's a lot of miles. Okay. I'll give you guys another second to copy that down. Okay, so the second way that we measure distance is what's known as an astronomical unit. Okay, the abbreviation for astronomical unit is AU, capital A, capital U. Okay, so this is the second way that we describe distance. Okay, this is measured or based on the distance between the sun and the earth, which is 93 million miles away. If I wanted to find out in astronomical units how far Mercury and the Earth was, you would do this in a multiple of AUs. So is it 1? Is it 1.4? Is it 1.7? So on and so forth. Okay. The whole thing with this is that they would rather say 1 astronomical unit than screw up with all the zeros. There are a lot of zeros in million and billion and trillion. So it's less likely for you to actually have a mistake if you use it at a smaller number. Okay, so they came up with these based on that. Okay, so now let's do a regions question. Right? What is approximately the size of the solar system? Is it 384,000 kilometers, 1 astronomical unit, 100 astronomical units, 1 light year, or 75,000 light years? I'll give you a minute to try and figure it out. All right, so what do you guys think it is? 1, 2, 3, 4, or 5?
3.
3. Okay, we have one person who says 3. Agree or disagree?
Agree.
Agree. Okay, that's 2 people out of like 28 of you. How about the rest of you guys?
I was stuck between 4 or 5, but I'm not 100% sure.
Okay, so let's figure it out, right? At the bottom here, it says 1 astronomical unit is the distance of the sun to the earth, which is about 150 million kilometers. Okay? The entire size of the solar system is not 150 million kilometers. Here's a hint, okay? The Earth is the third rock from the sun, right? The third planet from the sun. But the distance between the two, if you look at it on a map, is only this big compared to the whole map. Okay, it's only like that big, right? So it's not a lot. So 150 million kilometers is only this much of the entire solar system. So number 1 and number 2 should automatically be out, because 384,000 kilometers is a lot less than 150 million kilometers, right? Which is the answer to number 2 as well. So those two should be out. 75,000 light years. So let's do the math, right? We said that 1 light year is about 6 trillion miles, right? Just right here. I told you to memorize that, right? 6 trillion miles. That's a lot to begin with, to then take 75,000 of them, right? That's not going to work. That's going to be too much. So 1 light year is 6 trillion miles, right? That's a lot, right? That's a lot bigger than just our solar system. Our solar system, for those of you who said it, is 100 astronomical units, or about, what's 150 million times 100, guys? 15 billion? Does that sound about right? Hello? You guys have calculators? I don't.
Yes.
So it's about 15 billion. Okay, so it's still very large, but it's not crazy large, right? Because you have to remember that we're one solar system within our galaxy, right? Which is inside of our universe. All right. All right, so let's move on to the sun. We started talking about the sun a little bit, but we're going to talk about it more in detail. All right, so the sun, first of all, is a star. It is a medium-sized star. Now, some of you might be like, but it looks so big in the sky compared to the other stars. Well, yes, it does, but it's all about perspective, right? If it's closer, it looks larger than if it's further away. So all of the other stars, I just told you, besides the sun, the closest star to us is Proxima Centauri, right? And Proxima Centauri is pretty far away from us, right? So it looks like a dot in the sky. But that doesn't mean that it's not a large object, okay? It's all about your perception. The sun is a medium-sized star, okay? The sun is made up of basically gas. All it is a bunch of different gases, specifically hydrogen and helium. Okay. Now, just like our planet, as you go deeper and deeper and deeper and closer to the core of the sun, it's going to get hotter. Not that anybody has gotten that close, because you'll basically burn your skin off before then. Okay? Now, the sun has that central force known as gravity, okay, that will actually influence the planets in their orbits. It's what keeps the planets in their orbits. It's what keeps them revolving around the sun, is that mutual gravitational force between the sun and the Earth in this case, or the Earth and the sun. It's a mutual gravitational pull, okay? Okay, we'll come back to that slide in a minute. All right, the big thing about the sun is it's our only source of energy and heat and light. Okay, without that light and heat and energy source, we would not have light. No plants could survive, right? Because you remember from last year that process of photosynthesis, right? Where the plants have to absorb the sunlight to then have the carbon dioxide be turned into oxygen and have the plants grow more, right? We need the sun as well. We need that vitamin D, right? If you go outside, some people actually during the pandemic got low vitamin D situations because everybody was hiding in their houses and not necessarily going outside. And they're starting to notice that when you do your blood test that your vitamin D is low. Okay, so you want to make sure that you keep that up. You go outside every once in a while, even if it's for like 20 minutes a day. That's better than nothing. Okay, and again, everything is held in place by gravity. Gravity is the only reason why we stay orbiting around the sun. Okay, here's the big surprise. About the sun's mass is about 99% of our solar system. That's a lot, right? Now we have all these planets and we have their moons and we have this, that, and the other thing, okay? But it still only falls in that 1%. That should tell you how large the sun actually is. It's huge. Even though it's considered to be a medium-sized star, I'm going to show you a video later on when we're doing more of the astronomy unit, and it's going to show you how small we are and our sun is in comparison to so many other stars. Actually freaks out a lot of people, which I think is hilarious. So what I want to do now is I want to show you a little music video. Yay for music videos. Okay, this music video is by They Might Be Giants. They're actually very informative, and I want you to listen to it very, very, very carefully. Okay?
This holiday,
Marshall.
keep firmly connected with Fios, the fastest internet in America. With all of us using different devices.
Thing that they talked about. Here we go. Okay, so right here, blurry. Why are you blurry? There we are. Okay. What this part of it is, it's looking at an atom of hydrogen from the inside. Okay, so this red part out here would be a magnifying glass. You can't actually do this with atoms. You cannot see them under a magnifying glass. Okay, just a little disclaimer here. All right, but what it's showing you is that it has an electron, right, and it has your nucleus in the middle. If you watch, it said it was a atom crushing machine. It doesn't mean that it was just taking atoms and going and killing them. No, that's not what it was doing. Inside of the sun, there's this process called fusion. F-U-S-I-O-N. F-U-S-I-O-N. And what the general version of fusion is when you take two smaller elements or two lighter elements and you force them together to create a larger element. Okay, I'll say it again. It's when you take two smaller elements and you force them together to create a larger element. Okay, in this case, in the sun, we're talking about taking two hydrogen atoms, right, and you're forcing their nuclei, their nucleus, the inside, together, and it forms into one larger atom called helium. Okay, now why do we have to force it together? Well, because the nuclei, the only charge inside the nuclei is a positive proton. Okay, the number of it just depends on which element that you have, but that's besides the point. I want you to focus on the fact that they are positive. Because if you try to put two positives together, and you fight and you fight and you fight, it flips usually with magnets, right? You're forcing the two magnets together, it fights you eventually and you cannot get it together. Unless you undergo a process called fusion, which needs an extreme amount of pressure and heat or energy in order to do that. You have to overcome that nuclear repulsion where they don't want to be near each other and they'll move away from each other. Okay? That's what's happening inside of stars, is this process called fusion. And it'll keep happening where the hydrogens will come together and knock into each other in such a way in forming a larger atom until there's no more hydrogen left to do that. Okay? Now, that's important because when you're talking about the sun in general, right, this is how the sun was created. All right? So, when we are looking at this, right, remember we talked about the heliocentric model, right? In the beginning, the sun god, the Greeks called him Helios, or Helos, okay? That's why we get the heliocentric model. It's the sun-centered model, right? The mass is 333,400 times the mass of the Earth. It has a diameter of 1,392,000 kilometers, or 109 times the Earth's diameter. Its gravity is 28 times the strength of that of Earth's. Okay? Its surface temperature will actually vary from 4,500 degrees Celsius to about 15 million degrees Celsius. Or that 151 degrees? Oh, 15 million. Okay. 3, 4, 5, 6. Yeah. Okay, that's ridiculous. All right. It does rotate, though. All right. The sun does rotate, and it's tilted about 122 degrees. So that's like, if this is 0, this is 180. It's like here. Fun times. It's kind of upside down. Okay. So that's basically the sun. And honestly, that's where I want to leave off for today. I'm not going to dismiss you. I'm going to go over your quiz now for those of you who still have questions on that.